Welcome to Luca and Miguel. Enjoy the video.
You start by validating prerequisites so nothing blocks later steps. First, confirm the host has a supported NVIDIA driver and matching CUDA runtime. Run NVIDIA SMI to see versions. Next, install Docker Engine if missing, then add the NVIDIA Container Toolkit package and configure the Docker daemon to use the NVIDIA runtime. Once done, restart Docker and rerun NVIDIA SMI on the host. This ensures Docker can access the GPU, and that driver toolkit alignment prevents runtime failures. You now build and launch a GPU-enabled container. Begin with an image that matches your host CUDA, for example NVIDIA/CUDA with the proper tag. This avoids ABI mismatches. In your Docker file, install dependencies and copy your application, keeping layers slim so GPU libraries remain consistent. Build the image, then run it with docker run gpus all or the legacy runtime equals NVIDIA, and bind mount datasets or devices as needed. Make sure container permissions allow access to /dev/NVIDIA devices so GPU calls reach the driver. You finish by validating runtime behavior and fixing common failures. Inside the container, run NVIDIA SMI and a quick CUDA sample. If GPUs are absent, confirm host driver and image CUDA match, and that Docker was restarted after toolkit install. If permissions block devices, check group membership or UDEV rules. On hardened systems, inspect SE Linux or AppArmor denials. Once resolved, you can pin GPUs with gpus device equals 0 for reproducibility. A quick tip: check daemon, JSON and container logs for clear errors to guide your next fix.
Thanks for watching and please subscribe. It's the best investment you'll ever make.